Alrighty, are we live? Are we live? Let's take a look at that. Yeah, should be live. Should be live, yeah. Alrighty. Alrighty. Core count, Phil. Good evening, Phil. Good day. Good to see you again, man. Thank you for coming. Give me 1 second. I just bought a new, just some new notes. I'm out of paper, so I had to go. I attended my Danish classes, my lesson. I've been to Danish school, and then I ran back for like 5 kilometers, and then, you know, I'm like, okay, I'm gonna go to store and buy some new paper because I'm out of paper, and I love putting my ideas on the paper. How are you doing, man? How is let me just prepare here. Oh, nice. This is the best tool on the planet for drawing. Pen and paper. There's nothing yet better than that. Ah, new pen. Let's see. Nice. Beautiful. Super. All right, we're ready there. Yeah, so yeah. What we're going to be doing today, we're going to continue with our journey of Kubernetes, and soon we're going to have to go back a little bit back to building the programming network. There are a few things I want to build, but we'll see about that eventually. And until we get there, give me 2 seconds. We'll yeah. We'll continue our Kubernetes thing. Kubernetes. Exactly. Yes. Cool. So yeah, I did a lot of stuff here. And I feel your pain, man. Yeah. But still being here, man, I appreciate it. Thank you. I already feel the support, so no worries. Yeah, I'll continue somewhere. So fundamentally, I have. So let's take a look at that. So we have everything's fine. We have our cluster-related things running. So we have Longhorn running. We have our Traefik running as well. These 2 dashboards in our local host that we just had. We've just added some Etsy hosts records. Basically, because we don't have a DNS here locally, obviously, we've just so we have our Etsy hosts, and that's working. So now what I want to do before we move on to setting up MetalLB again, and then following by that, so let me just write that down. So what we're gonna do, we're gonna set up 2 external drives. So set up 2 SSDs, because now we have 6 SSDs in total. We're gonna set up metal load balancer, right, today. And then we're gonna do the proper etcd, so proper K3S backup. And that's sufficient for now. Yeah. So what I'm gonna do is, and then we're gonna, of course, learn some stuff. We're gonna play. We're gonna make our, as I wrote here. And let me actually just pinpoint this here. Let's just say this. That's the repo that I'm building, and then I'm going to start recording probably this week the course on Kubernetes. I already kind of pre-recorded some stuff last night. I was just playing a little bit with it to get an idea. It's been a while. Cool. So yeah, so we have our Longhorn dashboard, and we can see that, yeah, if we go to Longhorn, we go to nodes, we take a look at each node individually, we see that each node is using our SSDs now. No, we got rid of We got rid of the SD cards. And I have two SSDs now that I plugged into Raspberry Pi 3 and 4 that I want to format now. So if we go to, if I do SSH RP4, or no, let's do the RP3 first. Thank you very much for the follow, appreciate it. So if we do lsb block, we can see actually here that we have, so this is our, yeah, this is our operating system, right? Just as a point of reference, right? So I have recently bought a bunch of new hardware for this, and we have it all documented here. So now we're using 4 of these guys for the storage. So if we actually go to the cluster, you can see that each Raspberry Pi now has a SSD plugged in, and that's basically this crucial BX500. It's pretty awesome. You can see it's the most sold hard drive there is. Nate, hey my friend, good evening, good to see you, man. So yeah, so we have 4 of these, and then I bought 2 other ones recently as well before these 2. Where is it? I think we bought, hopefully I didn't nuke them from this list. No, it's these 2, right? And then we have 2 of these that we're gonna format now. So these are the smallest ones I could find, 128 gigs. So if you take a look at this, that's most likely this guy. I could, Nate, you also have the link there. I mean, I'm documenting everything down, so soon there's going to be video lectures on this, but everything is documented here, right? So you could just as well, I've included this link, so I'm pushing this, right? But, of course I can do that for you. I mean, in short, we are not really doing this for the sake of a cluster per se. We are... yeah, we'll speak about it, Nate. We'll speak about it. I promise there's going to be an awesome video series, but I'm writing everything down. I mean, my goal with this project is that we build the most amazing content on the internet when it comes to K3S. And I'm not exaggerating because I want it to be very practical. So take a look at the outcome and take a look at the why. And then we'll speak more. Just so yeah. All right, so let's take a look at this. So yeah, here's my drive. And as you can see, there's no mount point here. My pleasure, man, my pleasure. So here's the SDB1. So this is in fact a partition. So there is some partition, right? We could in theory mount this. So I could say mount, so lsb, right? And I think I actually wrote for mount and format drive. Yeah, we actually need to include this as part of the new documentation. But you can see umount fdisk. So let's use the fdisk now. So we're gonna say here sudo fdisk, and then we're gonna point to SDB, right? Our second drive. So now it's asking us what do we want to do. I wanna remove the current partition, right? So I'm gonna do delete, one partition deleted, right? Then I'm gonna create a new partition, as you can see, n. It's gonna be primary partition. Rest of the stuff, I'll just say it's default one, yes. And then at the end, as written here, I'm gonna just type W for write. Bam. So now if you go lsblk, here it is. So we'll still have it. There's nothing on it, right? And now we need to format it using mkfs. So we're going to say sudo mkfs ext4 type dev and then sdb1. Now it's going to format the drive and we're good to go, right? Now we can mount the drive. It's all documented here. So I'm going to say here, let's say again lsblk, and I'm going to say sudo make dir p. So I'm going to create some directory that we're going to mount to, right? So I'm going to call this, how is the name of this disk? Crucial, no, that's not the one. Where's our hardware section? Hardware components. I don't know if I want to call it verbatim, I don't know. Yeah, let's call it like that, sure. Verbatim SSD. Yeah, so we're going to create this directory, and then we're going to mount this directory. But then we need to make sure that this is also mounted during the boot of Raspberry Pi. So we're going to say sudo mount dev sdb1, and then we're going to mount that mnt verbatim SSD, right? And then it's complaining about something, so we're going to reload the... Yes, going to enter our password here. Authentication complete. Okay, so now if we do again, we should see that this now is mounted. And now, in fact, we can add this drive to the actual Longhorn, right? So if we go to our Longhorn, we're going to find the node Raspberry Pi 3, which is this one. This is internal cluster IP. So we're going to go here, we're going to edit this thing, and we're going to go down, we're going to say add disk. Let's call this, I'm going to tag this as just going to invent that tag, and here I'm going to give it the mounting mount path, which is mnt verbatim SSD, right? Scheduling enabled. This means that Longhorn can use it to schedule things, and the name is going to be SSD. And yeah, I don't want to use the block because I don't want to explain. So now if we save, we can see unschedulable. So Longhorn didn't actually add it yet, but soon, if we've done everything fine, we should be schedulable, and then it should show the space in here. Actually, let me actually hide this chat from the screen. Yeah, there we go. So now we can see that disk now can be used, in fact, by Longhorn. If we go back here, we can see that space we actually have is increased by 128 gigs. So that's pretty cool. Let's go back and finish this stuff, though. We need to update the fstab so the disk is actually mounted during. If I would reboot now the Raspberry Pi 3, the mount point would be gone. We do this so we can get unique identifiers UUID, right? So as you can see, you will see the output, blah blah. So we want to get the UUID of the drive, right? So let's find it. So here's the UUID. It's a very strange UUID whatsoever. It's because it's a wrong disk. That's why we care about SDB1, right? Because that is the disk. It's this one here. This is the UUID. So I'm going to copy this UUID. And I'm going to temporarily save it in here. Then we're going to edit this fstab. Yes. And then as you can see, there's already some drives here. So we'll append our own, right? We need to be careful not to mess this up, because sometimes we can even brick the Raspberry Pi from not booting up anymore, because if we try to boot up a drive that's no longer there. So we need to give it a UUID. Mount point, which is in our case was, what was it? I think I actually have it here now. It's easier. So I'm going to go over here, edit. So it was, this was the mount point, right? Yeah. So this looks reasonable. Yep. All right, so let's edit the fstab. Actually, we are already in the edit mode. UUID is there. So let's grab that. And we can just paste it here, right? Yeah, that looks good. Let's save. No, I don't want to save on there. Wait. Yeah. All right, there we go. And now if we hopefully reboot, hopefully if we've done everything fine, it's going to be good. I have an Ansible story for this, I believe. It's right here, but I'm not going to use it because I'm a little bit scared of using it right now. But we do actually have a way here to, you can see Ansible playbook. give it a disk device, but I'm not going to do it now because it's just 2 disks. If it was 8 disks, I would not do it manually, but now I feel more confident. All right, so RP3, ooh. Connection refused, shit. All right, let's give it a second to boot, hopefully. Connection refused still. Yeah, we can see that it's not ready yet. Yeah, hopefully we didn't mess it up. Worst case, I'll just reboot it. But yeah, we can see that it's not ready yet. Yeah, it doesn't seem that it's gonna get ready though. But let's give it a second because there's a new drive now, so maybe it's, yeah. Yeah, okay, good. We're good. Yeah. Cool. So now we have that SSD added. Okay, good. Just took a while. So let's do the same here. Pretty much gonna do the same. We can see the disk here, right? So we'll pretty much do the same. Let's just actually. All right. It's not mounted. Good. So we're gonna do the same. Dev SDB1, SDB1, right? And they make sure I don't format the wrong disk. Yeah, I'm gonna delete it. No partitions is defined yet. Okay, we're gonna create a new one, primary one. Gonna nuke all of this stuff, the defaults. Then we're going to write, and now we should format this, right? So we're gonna do sudo dev sdb1, right? Actually, I don't trust myself, so let me show. Yeah. Found the DOS partitioning table. Okay, so something we haven't done properly. Let's try that again. Partition deleted. Create a new one. Primary. Yeah. Write it. Ah, I see. Okay. Thank you very much for the follows. Appreciate it. That's cool now. So we have formatted that hopefully successfully. Now we're gonna do the same as we did with the other disk, right? So we're gonna, well, what did we call the other one? Let's SSH into our Raspberry Pi 3. So we call this mount point like this, right? So we're gonna do the same here. So we're gonna do, and then we're gonna create the same directory, right? Cool. And then we're gonna mount that. We're gonna say dev sdb1, right? And then we're gonna provide it that same thing. Cool. We'll reload the systemctl daemon. My pleasure, man. Give me 2 seconds. Okay, cool. So this disk in theory should be mounted. Now it is, and we're gonna do the same. We can run the yeah, cool. And then we're gonna do the same. We're gonna get the UID of the disk, but SDB1. Now, so this one. Let me just clear this. This is our UID. So I'll grab it as before. Just save it here temporarily, right? Then we're gonna need to edit our fstab. So we do the same here. We do this, right? And then this is gonna be, what was the mount point? Yeah. Yes. Beautiful. That seems correct. We need to be careful here. All right, and then we're gonna, or vim, whatever. And then we're gonna smack this guy. Ah, we didn't copy that properly. What the hell is happening? Okay. Yeah, I don't know. This thing sometimes just, let's just close that and reopen it again. Oh, I see. Cool, cool, cool. That seems correct. Yes, and we save, right? And we're gonna, of course, reboot the Raspberry Pi 4, right? So we're gonna wait for that a bit. So we should see that status is not ready soon of this guy here. So basically, this guy right above my camera, that is the fella now that we are setting the extra drive with. Okay, good. Yeah, it's this guy we're gonna wait for now, and then once it comes back, we'll yeah, so we can see it's down. So we're gonna then add the disk there, and then we should have around 800 gigs. It doesn't really, I don't actually care about the space. I just need this for our Longhorn, for the replicas, for the replicated data. And then we'll create a, then we'll actually, oh shit, I forgot to write that down. We need to set up the PG, native PG operator as well. So our database cluster, our Postgres cluster that's gonna then utilize this persistent volume. So set up native, just writing this down, native PG operator. Cool. Oh, why am I sharing the full camera? Jesus Christ. Not ready yet. Okay, let's see. Yeah, it's almost there. It's almost there. Cool, cool, cool. Should see it here soon. And then I think, did I write that part of the guide or guide for myself to say if I go to networking and if I go to, we're gonna do this, we're gonna set up Metal load balancer later. This is what we've done. This is what we databases. Yeah, cloud. So yeah, so this is what we're gonna have to do in a second. Okay, they're all ready now. Nice. Let's just check that mount point. It's there. So we'll just go to our Longhorn. We're gonna go to, we can see that the Raspberry Pi 4 now works. So we'll go here. You can see that some modules are not installed. I'm not sure. I don't know much about this. So I'll just create a tag randomly. This is the mount point, and I'm also going to call the disk, the space here, verbatim SSD. Schedulable, yes, save. And then here it should actually appear in a moment. All right, there we go. Beautiful. That works. Yeah, and now our Longhorn has, so we have a lot of space on our cluster to just create persistent volume claims and storage classes and a bunch of that stuff. So it's all SSD, so we don't have any HDD. So we don't really need any of this, actually. This is a massive overkill, but it's fine. This is all for the sake of learning and for the sake of, yeah, having something that we can see over the year or two. This is a test for me. I want to have these drives running as long as they can until they die. And that's going to be some showcase of how this equipment actually survives when it's actually used 24/7, because this cluster is plugged in 24/7 pretty much. So cool. That's great. All right, great. So that part is done now. Now, next thing we want to do, if we go to the guide that I'm writing, is, yeah, so let's actually go to localhost, because we're going to be writing more of that. Whereas Kubernetes, this is databases. So now I want to set up the Postgres cluster again that's going to utilize this persistent storage. And then after that, I probably will want to do the K3S backup properly. For the first time, I've never done this. We need to back up several things, actually. I've been reading a little bit about it. So if we take a look at the backup here. So yeah, so we'll need to back up this directory. We're going to have to back up our token. So we're probably going to create a Ansible playbook for this that's going to do that. We'll probably generate one with OpenAI, but we'll need to back up the SSD, so the distributed database that's part of the Kubernetes, because this is where Kubernetes, this is what control plane interfaces with, and so this etcd is in fact the most important thing in our cluster. This is what we need to back up, because this is what holds namespaces, config maps, services, and all of the other things, right? Celia Cruz, good evening, friend. So, but let's before we do that, let's do the last thing, which was which is setting up the. And then I said I'm going to do backup later, because I don't want to do this again, because we will at one point mess things up undeniably. I actually don't think I'll need to update this part of the guide. I don't think we need to manually create the namespace, because as far as I saw in this YAML file, I believe that the actual template is going to create a namespace, exactly the same namespace by this name. But yeah, this is now, okay, let's go as I wrote here. Let's make sure that right now my article here is pointing to the latest version, 124.1. 124.1, yeah, exactly. So let's now start with the CloudNativePG. For those of you who don't know what this is, CloudNativePG is an operator for Kubernetes, basically. So now our Kubernetes is going to be stateful. So we will, in fact, host a database as part of Kubernetes. And this is an operator. What is an operator, you might wonder? It's a pattern. It's a Kubernetes pattern. The word operator comes from a literal person, a human being. As you can see, it's going to say the operator pattern aims to capture the key aim of human operator who is managing a service or set of services. Human operators who look after specific applications and services have deep knowledge of how the system ought to behave, how to deploy, blah, blah. So in simple words, when you create these Kubernetes operators, basically you are creating rules of how, let's say, a person would operate a specific technology for whatever the operator is for. In this context, this is a Postgres operator, so some guys who are expert in Postgres, who know how to manage Postgres themselves, wrote an operator that, yeah, well, manages Postgres for us inside of the Kubernetes cluster, right? So as you can see, of course, buzzwords like in every other place, high availability, disaster recovery, monitoring, that's, of course, all expected from Kubernetes naturally, right? So that's why we are setting this up, because, yeah, obviously I need a database is the most fundamental part of your stack. Without it, everything is nothing, right? Okay, cool. So now when we know that, let's come here and, yeah, let's run this. Let's run this kubectl apply and hope for the best. So we're going to use this, You're going to use this tool that my colleagues from work, my amazing colleagues from work, have showed me, Patrick and Moshiko. Hey, how do I actually? Okay, cool. So let's go actually manager. So we have some logs here. That's not what I really want. I don't want a tail. I want to have. Let's actually go back. Okay, so let's see what we got here. So we have Longhorn. Where's my? I should see some. Yeah, here it is. So this is the controller for the PG operator, and then these are the logs of the operator itself. But I would like to see a bit more. So log. I'm not doing it for fun. There's an article linked there. You can read why am I doing it under why. I never do anything for fun. Because if I wanted to have fun, I would play my saxophone or my guitar. I would not be doing this for fun. Okay, cool. Well, either way, I actually can't see much of it here. One default. What can I actually log? Huh. Actually, you know what? Let me kill this session here. Let me open a new window maybe here. Yeah, just like this. Give me a second. Okay. I'm not doing it for, I mean, everything that we do in life, there's some fun to it, of course. But I've linked the article in the top. You have the article linked. This is the guide I'm writing. And there's a why section. Why am I doing this, right? I don't think that I would, after a full day at work and Danish classes and wife and kid, that I would necessarily sit here just if this was for fun, to be very frank with you. I don't think so. So it's a fun is an integral part of life, of course. So it's not that it's boring. It's incredibly awesome. But I'm doing it for reasons that I stated there. Okay, cool. Nerdy Biker. Good evening, buddy. Okay, good. So it's linked there on top of your chat. It's already linked. I hope that you can see it. I pinned it to the top of the chat. You should see it on top of your chat. I guess Twitch should do a better job there. Okay, what did I want to do? So let's say kubectl get NSA. So we have the Cloud Native Postgres operator here. My pleasure, man, of course. So we have the service there. That's cool. We have some pod running, right? I think it was what pod and then like this, right? And then, yeah, exactly. And then we give it a namespace of, what was the namespace? CNPG system, right? CN. Yeah, I actually don't remember what was the. I think I wrote it somewhere here. Give me a second. Cheat sheet. How did I call it? Doconosaur, SRC. No. Docs, yeah. What we'll learn, networking storage, Kubernetes. Common commands, yeah. Where's the logs? Logs, pod name. Okay, so I guess that pod is unnecessary. So kubectl logs, and then the name of whatever, and then we're missing an N there. It's okay. There we go. Okay. So that all seems fine. So in fact, that seems great. Let's actually open up our clusters Traefik here. Let's see what this dashboard. It's not very useful, but let's see what we have. We have services. We have 7 services here. Kube system Traefik internal. So yeah, not much is useful there, is it? So let's go back to dashboard. Routers, middleware. What am I looking for? I don't even know. Services, HTTP routers. Yeah, so there's nothing exposed really here, which makes kind of sense, right? Because we're talking about a database. So it's not exposing any HTTP, HTTPS service, right? Or any dashboard or anything like that. So that's kind of logical. Okay, so that's good. Next thing, what did I write under PG setup cloud native PG? So let's go back here, or even maybe better, let's just go back to here. Okay. So yeah, this is what we just did. Let's just do it once more. So we can see that it's running, the controller is running. And now we want to deploy the cluster, right? I've set up my K3S months ago to learn the basics of DevOps, but I don't have much time because I'm preparing for that job. Yeah, I mean, again, as I wrote under the section there, right, I've been doing this partially for 2 decades almost, right? In 2007-8, I worked as Cisco engineer and sysadmin. So, of course, not the Kubernetes itself, but fragments of this, right? And I use Docker since it exists pretty much, right? So it's not something that I'm playing with. It's rather, as I described there are several reasons why I need to do this and why I want to do this, right? And maybe you might have 0 reasons, as I wrote, right? So if you go to that link, right, you know, some of you know me by now. I'm not an influencer. I actually don't care if you're going to learn it or not. I mean, to be honest, you get what I mean. I do this stream for myself. All right, some of you are going to do something I absolutely don't care, right? And that's why I'm always very open and very direct, right? Most of you probably shouldn't do this, right? Most of you, I know that predominantly these streams, it's either young people here or people without jobs, or it's very rare that people, right? So people come here, so there's probably a bunch of other skills that many of you here can get today and to uplift yourself in your career than learn this, right? But for those of you who can, well, of course, stream during these series is going to be useful, but I'm not going to tell you, oh, you should learn Kubernetes. You probably shouldn't learn Kubernetes. There's a high chance you shouldn't learn Kubernetes, right? So that's just how it is. That's the reality. I'm not going to sugarcoat it just because I'm streaming it, right? Most people shouldn't learn Kubernetes. And most companies, 99.9% of them, shouldn't use Kubernetes either, right? Because they don't need it. They don't need most of the features it offers. No, man, please. It's a great question. Why is always should be absolutely the most core fundamental question. And that's why I also wrote, no matter what I do, no matter which YouTube video I record, why is always first, and for some people, the last question they need, right? As you can see, even here I wrote, hey, these are my reasons for learning this, but what are actually yours? Your reasons might not align with mine at all, and most likely they will not, right? So learning something because it's cool is absolute waste of time, because you can actually learn something that's useful to you at this point in time for your career at this point in time. Or should I learn Rust? No, you should probably learn CSS, because most likely that's going to benefit you more, right? Should I learn, I don't know, C? Yeah, probably not. Probably something else is going to benefit you more. So if you have the time to kill, and I'm just talking to everybody, learn something that can actually help you quickly, that can increase your value quickly. So now we're going to create a cluster, Postgres cluster like this. We're going to choose how many instances we're going to have. Because I have 3 worker nodes, I'm going to say that because actually also that's what we didn't configure. I want to make sure that my main master node, my Raspberry Pi 1, the one to the left, in fact, isn't running anything other than the control plane, because I need to make sure, because if we go ahead here and say kubectl top what was it? Top nodes, yeah. So we can see the utilization, resource utilization on these Raspberry Pis, right? If I go to the master node here, do I have btop? No. I'll just install it very quickly. So if I do btop here, right? CPU at 33%, what do we actually get here? Systemd, so there's probably some of these things we can disable to optimize. We can write some Ansible story playbook for this. But yeah, mostly it is already kind of optimized, right? We disabled the Bluetooth, we disabled the swap, we disabled the Wi-Fi. We tried to optimize the fan speed, but due to the absence of additional pin on our Raspberry Pi fans and the absence of some other things, we couldn't really optimize them too. But yeah, we could, in theory, optimize how much. Let me see, I have a power plug. How much electricity is my stack using right now? Give me 1 second. So you can see right now, I don't know if you'll be able to see it, but right now the cluster with 2 MikroTik routers is using 35 watts of power. So if we would decrease the voltage and the CPU clock of the Raspberry Pis when they're idle, when they're doing nothing, right? That could potentially do 2 things: decrease the fans, or decrease the sound in decibels to basically nothing. So this cluster wouldn't produce any sound because fans would be off, and also could reduce the electricity probably by, I don't know how much power these fans draw, but yeah. Okay, I think I have this Postgres cluster YAML file already somewhere, right? Shit, what happened here? Desktop 1, crap, wait. Give me 1 second. I messed something up. What did I mess up? Oh yeah. So we have this, where's my browser? Oh, here, okay, I see. Cool, okay, so let's take a look at that. So we have Postgres, yeah, so here it is, Postgres, my Postgres cluster. So here's my cluster, right? And then we have the service, the load balancer service here. That's gonna, yeah, so this requires MetalLB right now because the type is load balancer. This means that we are basically exposing this outside of the cluster. So we would expose this database outside of the cluster right now. So we could have cluster IP in here and then port forward to this, right? So yeah. So I'm not going to do that now. So I mean, we can create a cluster, and that should work fine. Like creating a cluster should be fine. I mean, yeah, we can create a cluster. We don't really need to maybe expose it outside of here, right? We can then try setting up some nodejs app or whatever, and just trying to connect the API to that thing, right? And then over here, yeah, we don't really need to. When would we want to expose this? Like, I don't think that we ever really want to expose this database outside of the cluster, unless, you know, we need to, for example, use AppSmith or Retool or some of these dashboard building tools where we want to expose our database directly to some of these tools and then create a unified firewall rules that allow access to this cluster from that specific external IP. But I don't think that I'm going to do that. I do that for Programmer Network. I do that here on Hetzner. But yeah, I don't think we need to do that here, right? Yeah, okay, so let's forget that then. The size that we want to allocate to this cluster, 1 GB, right? We're going to increase that storage class. So yeah, we need to create a storage class, and I think my first storage class is the Longhorn one, right? Because if we go ahead here, and if we say, how do I, give me 1 second, how do I check the persistent volumes? Where is this document? Common volumes. How do I get the, yeah, exactly. kubectl get volumes Longhorn system. I think the Longhorn creates a default volume. Yeah. Really? There's no volumes. Okay, so we haven't created one at all, I guess. Yeah, so we do have this guy, but so we have no volumes. Okay, I see. Okay, that's okay. That's perfectly fine. Okay, let's go back here. So let's see what I wrote here. We create a cluster. We apply the cluster, verify Postgres pods. Yeah, there should be 3. Then we can port forward just to test outside of the cluster. Oh yeah, so this is what we haven't done, right? So we have the Longhorn storage class that we actually haven't created, right? So we didn't run this. So we don't have a storage class, nor we have the Wasser trinken. Okay, I actually will, thank you. So we have the storage class and we have persistent volume claim over here, right? That persistent volume claim, and then we have the ingress for a Longhorn, which this is what I've done, because this Longhorn, this is the ingress for our Longhorn dashboard here locally. Of course, we have to be careful when we expose this whole cluster to the internet, and when we start using it in production, we need to make sure that we don't kill this. So yeah, so we actually didn't create any persistent volume, nor we have created a storage class, but it's a bit weird because, to be honest, I thought that how can I get storage class? Is there a way to get this kind? Give me 2 seconds. So I'll just open it here. Common commands. Nah, common Kubernetes commands. I still suck at Kubernetes. I'm sorry. I need to read this. So PVC, no. What should I search for here? So basically, I want to check the storage. Get volumes. But we could also use the Kubernetes extension here for VS Code, right? So if we go to storage, persistent volumes, there's none, right? Okay, so let's create this storage class, even though it's a bit weird. Wait, let's ask the robot. Let's ask OpenAI, because I don't actually... let me drink water, 1 second. Okay, so what do we have here, Longhorn? How do I list Longhorn storage classes? Craft, my friend, good evening. Thank you for coming. I appreciate that. Okay, but why don't I have this in my quick commands? Okay, good. So, wait. Yeah, that's what I wanted. Beautiful. So we have, so we do have the Longhorn default. Okay, I'm just gonna tell it, okay, I'm just gonna tell it, update my README with missing commands. I really need to have this file where I can, until we memorize. As many of you know, we're not using Helm purposely based on the decision, because we don't want to abstract away these commands. We need to really, in the next month or so, just memorize all of this before we can then start. In simple words, we're going to introduce the tools when we start feeling the pain, not vice versa. Okay, so if I go now Longhorn, and let's just do this, right? I hate these things, man. when it uses these numbers, like, just gonna nuke all of that crap, man. No, actually I'm not. Don't have the time for that now. Fuck that. Okay, so yeah, I did. I'm really trying to make this awesome for myself before anything, of course. Not to act as some sort of a holy grail of morality. I'm not. I'll do this for myself. Okay, cool. All right, so we have the default Longhorn class, and in fact, yeah, we can create our own just for fun, mainly because we're gonna have our custom number of replicas and stuff, and because I don't know what the default of Longhorn is. So I suppose I can just say Longhorn like this. Can I say kubectl describe? Yes, nice. Okay, so let's see what the describe does. So yeah, so actually, so the default Longhorn storage class has reclaim policy delete, volume binding immediate, allow volume expansion true. So the defaults are actually pretty good. Stale replica timeout 30 minutes. So basically, it's going to treat a disk replica as obsolete, and it's going to need to, you know, sync it up if it's stale, if the data is stale more than 30 minutes or more. Number of replicas, data locality, I don't know what that is. Disable revision counter, I don't know what that is. And data engine, yeah, that's correct. Yeah, so we could use the default one, but for the sake of learning, let's just create our own. So we're gonna create here my first storage class. Yeah, we can do that. So we're gonna say apply, and then we're gonna go exercises. What was it? What are we working here with? P. Ah, my bad. So what do we have here? Longhorn, Postgres, my Postgres cluster. Nah, no, dude. I wanna do a Longhorn, right? And then we're gonna do the Longhorn storage class. Longhorn storage class YAML. We're gonna apply that. And now if we say kubectl storage get, what was it? Storage class, right? We should see it here. My first storage class. If we say kubectl describe storage class this, we can see pretty much it is the thing that we just described in the YAML. Let's just confirm that together. Kind storage class, metadata annotations, none, name, my first parameters, number of replicas. Yeah, that's correct. Cool. And then we have the persistent volume. If we go to our Longhorn dashboard, we'll notice that we actually have no persistent volumes. We actually haven't created one. We can actually even create it here through the dashboard, but I don't want to do that. I don't like that. So we're going to create a new persistent volume. Let's call it first. Let's call it Longhorn first PVC. Just we're gonna give it access mode read write. Storage, let's give it 20 gigabytes. And that's great. That should suffice, right? So now we're gonna just apply that YAML. So we're gonna Longhorn. What do we have here? PVC. Bam. So now if we actually go to the Longhorn UI, we should actually see it here appear. As you can see, it is indeed here. You can see that we just created a volume that we can now give to our applications that we provision to our deployment. So you can see here we have, in fact, the volume, we gave it 20 gigabytes of memory, of space. And then we can see it's going to replicate on these 3 drives, right? So as you can see, that's great, right? Because we're going to have Raspberry Pi 3, 2, and 4. And it's going to replicate it on the system level disks. We can see that by looking at the volume amount, right? So var lib Longhorn, I know that these are not my external drives. So I don't know, I haven't learned that yet, right? But technically I would have been happier if it actually used my external disks, which are these, which are mounted on mount verbatim SSD. But if we also go here now, we should in fact have 20 gigs more reserved here. Basically, it was 849 gigs, now it's 829. So basically, no, never mind. Yeah. And then we can see here in the logs that Longhorn Kubernetes controller has started some persistent volume. So that's great. Actual size created, data engine bound, default, and then la la la. And as we can see here, we have some options that I don't know how they work, but backups is something that I'm very interested in. So this is going to be something we got to learn together eventually. Not today, though. Okay, superb. So next thing we can do, right? Now we can actually provision the Postgres database and then give it these volumes that we have just created, right? So next thing would be set up CloudNativePG, going back to this. And yeah, doing what we have to do. So create a cluster, not expose it with a service, just port forward it and then see how it is, and then start provisioning deployments and creating apps that in fact use this Postgres cluster of 3 replicas. Okay, so I'm going to go now to databases, and actually there's one very interesting article. If you're going to follow this and learn from this thing that I'm writing, I researched a lot stateful part of the Kubernetes, because it's a huge discussion in the Kubernetes community. So if you decide to do any of this, make sure to read this, hosting databases with Kubernetes. I wrote this and then gave it to ChatGPT, to OpenAI, just to read proof and stuff. But some of these things that I wrote here are a huge friction point within Kubernetes community. Some people, especially those who are very loyal and huge hard fans, long fans of Kubernetes, are still against making Kubernetes applications stateful, meaning adding things such as databases to them. And they have a huge, they do have a point, many of them. Some of them are on the opposite side. They say, no, this is great, this is not going to be a problem. But either way, it's important reading here and understanding cons and pros of doing this, right? Because of course, no matter what system we are talking about on this planet, it can be your software, it could be whatever it is, really, keeping things stateless is always easier. It's a million times easier, right? So no matter what you do, managing state is hard. Either being a React app, your API, Kubernetes, if you don't have a state to manage, it's a million times better always. State is hard. There's nothing harder than state. Okay, cool. So now if we go here, yeah, so we're going to create now we're going to do another apply here. So we're going to go to Postgres, and we're going to create the Postgres cluster. I'll just take a look. So yeah, my first storage class, that's correct, because that's how we created the class. Let's actually just, yeah, that's good. So we're going to create a cluster, right? I'm going to create a cluster that's going to use this storage class that we created, right? So it's going to use this storage class, and that's amazing, right? So let's create this cluster. So we're going to say exercises Postgres, and then my Postgres cluster. Namespaces, yeah, and we forgot to create a namespace, right? So we need to do that as well. So we forgot to create a namespace somewhere. Yeah, so let's create a namespace, call it Postgres namespace. Let's call it, yeah, PostgresDB. What advanced techniques can be employed to optimize React component rendering, the optimization and the use of React context API? I'm not sure I understand your question. I mean, it's almost like a rhetorical question in a way, right? You don't want to use memoization unless you really have to, unless there's really something critical and you're seeing a bottleneck, right? Redux is definitely not going to optimize your application. Redux is going to complicate your state management, and unless state is really complicated, you have a lot of state transitions, you don't really need Redux, right? Redux is amazing. I actually wrote my own version of Redux like a decade ago because I really like the flux pattern. I like the concept of actions and action creators and reducers, and it's a very easy, very simple, and very well-defined and broken down concept. But in most cases, you don't really need a state machine such as Redux or any other now, I mean, everything that you wrote there is contextual, right? Context API is just a way to, you know, avoid prop drilling and to, I'm not a fan of context API. I think it's useful in many ways, but I'm not a fan when it's overused because it's breaking the main principle of web components in general. Components should be getting properties, props, attributes, whatever you want to call them. Some tools call them different ways. But fundamentally, context API breaks that, where you kind of cheat, right? You're passing data to components and coupling them in a way where it's very hard to understand what that component does. You have a component, you subscribe, under quote, subscribe to some data that lives somewhere. So that breaks the encapsulation of components. So in your scenario, you should try to keep your components as pure functions as always as possible, keep them simple, stateless whenever possible, and make sure that they take some arguments or props, as we call them in React, right? And in most cases, you don't really need to optimize anything in React, with very, very huge exceptions. If you're optimizing things in React with some removing the exceptions, you're probably doing something wrong, right? So you are either composing, your component composition is poor, it's bad, and you landed in a place where you now need to start memoizing or whatever because your components are re-rendering because how they're structured, how they're nested, how the props are passed to them, etc., etc. So if you, in 99.9% of the cases, if you are needing to optimize your React components, you've done something wrong. You've done something wrong. All right, so we've created this cluster now. We've created the cluster, beautiful. We need to verify that some of the pods are now running. We should see the 3 pods, basically. We should actually wait, let's wait for this. Of course, man, my pleasure, my pleasure. I wrote JavaScript for many, many years, and I wrote nearly every single new shiny thing that came out, and then at one point you stop caring at one point, basically, because these things in JavaScript world, they change rapidly. React is a beautiful technology. I'm happy that you chose it. You made the right choice. It's just keep things simple, right? And of course, keep things simple requires experience, knowledge, a lot of failure, a lot of failure indeed. But once you get there, you start appreciating things such as React, because a lot of people who ditch React, they actually suck at understanding the core concepts of building web components, regardless of the technology, right? Because once you conceptualize applications in the browser properly, once you can wrap your head around how do you compose components, what do you do, then things suddenly become a lot easier. Okay, so it's still initializing the cluster, yeah? And then we're going to port forward. So we're not going to use the service that I wrote. So we're not going to use the load balancer because I need to set up the metal load balancer again, the bare metal one. But even if I did that, I'm not going to expose the database outside of the cluster anyway, so that is fine. We'll just port forward it locally for the development purposes. So we're going to have either port forward, or we can use the node port or something like that, and that is just so we can test it here. But we need to wait. I don't know, it's taking a while, right? So you can see 2 of the pods are almost running, and there should be three replicas, because that's what we did, right? So if we take a look at Postgres cluster YAML, we can see that we have 3 instances. Storage is only 1 GB. That kind of sucks ass, but we can just reapply this. And actually, I will in fact reapply it in a second. I just want to see how fast does it do this. So when we reapply a Postgres cluster, does it like tear everything down and start from scratch? And actually, I'm going to remove this. I remember having this, and I know why I have it, because I don't want it to create a default thing. I do actually want it to do this now. So I'm actually going to comment this one out. And I'll apply this again. Now, in the middle of this process, just to see what is it going to do. How is it going to react to this now? So if we get the pods again, pod initializing. So I guess, yeah, let's see. Give me 2 seconds. Sure, let's go with that. All right, so we have these guys running. We have the kind which is cluster. So I wonder, can we say kubectl get cluster or clusters? Okay, and then can we say, what was the namespace? PostgreSDB n PostgreSDB. Okay, we can in fact, great. So we have my Postgres cluster. Clustering is in a healthy state. So if I now say logically, I suppose, get cluster, and then I just provide the cluster name, my Postgres cluster, we're going to get that. But then we can then say kubectl describe. So we can see, right? I'm so happy to write these commands manually, not using any abstraction yet, because we can kind of slowly see the patterns. It's like there is a pattern in this, right? So you use the describe. So these guys who build Kubernetes, I respect them for that. They unify that interface, right? So no matter what you want to describe, is the pod, you really say kube control describe kind, whatever the kind is, namespace, cluster, storage class, pod, whatever. Okay, watch to see it. I see. Okay, that's a new thing. And a good evening, localhost. So this is great, right? So we can see a huge YAML file here of our storage class. And basically we can see here, sorry, of our cluster, my process cluster, we can see here some metadata, the spec. Most of this stuff, of course, we can't understand. This understands the underlying knowledge of setting up Postgres. But we can see that there's bunch of things in here that I guess over time, over years, it probably take years to get into details. We can see that, and as local set said, we can do -v to watch, right? But not here, but when we are actually checking the, where was it? Yeah. Either way, that's great. Okay, now we have the cluster. So now we have the cluster. That's amazing. Let's actually go to, let's do this. And if we actually go in here, this is our little tool. So if we go to this Cloud Native Postgres thing, so we can see some logs in here as well. Sure, yeah, not that useful to say. Let's say mark toggle auto scroll, toggle timestamp, so we can see the timestamp there. Toggle auto scroll S, basically that's like watch, I suppose. Toggle full screen, cool, clear. MB95, thanks for the follow. Good evening, Masta. How are you doing? Masta. Plush master. Clear. Okay, let's go back. So actually, this is what I want. Attach logs. But I don't want the logs. What I want is shell, okay? Show port forward, okay? No port forward defined. Great, this is so awesome. But actually, what I want here is something else. So how do I get to the pods and stuff? Yeah, we're setting up and creating a guide on full K3S cluster here, as you can see, with a lot of cool stuff. So where can I, oops, I keep doing that mistake. So wait, this is my, can I go up more? Show node, okay, so it's RP3. Transfer YAML, okay, so we can also see the YAML here. That's very nice, right? Okay, I need to really start using this, an amazing tool. It can help us a lot. But it's making us not learn the commands by heart, right? So that's why I don't want to use it fully yet. Let's memorize all the commands. All right, and then lastly, now we can port forward this outside of the cluster. And I'm going to do that. I'm going to create a service, as I said. So just going to do this, and bam. My Postgres cluster not found. Okay, how did we name it? My Postgres cluster. Port forward. Okay, yeah, I see. So PostgreSDB is the namespace, my Postgres cluster read write. Okay, so maybe that is the problem. Maybe, and that's the cluster IP. So maybe that's what we want to port forward, right? So like this, maybe, right? Yeah. Okay, so now in theory, I should be able to connect to our local host, to our cluster here, right? From this computer from which I'm streaming. Password authentication fail. Let me actually see. I have Docker Compose running something else on this computer. Let's make sure I have something else for program network. Is this all down? I hope it is. Yeah, this is all down. Okay, good. Wait. I'm using everything is in the document described above. If you click on the pinned document, you have all the hardware and everything is there. Okay, nice. Okay, so I can see that it's exposed. Let's just see why is our password wrong. How can we actually check that? My Postgres cluster, no, so this is a service cluster. My pleasure, man, my pleasure. It's just, okay, so password authentication failed for user app. So it's just, I don't remember now. So what was so are we actually exposing the right port? We are port forwarding that, right? So that's the last thing. What was this thing? How can we inspect that? So if I go to Kubernetes, maybe to not nodes, to what would it be? Namespace. Yeah, I mean, PostgreSDB. It's a namespace, but that's not what we want. Storage, maybe. Persistent volumes. Custom resources, no. Configuration, config maps. Or maybe secrets, even. So that is the only thing now that I... Localhost Postgres. Yeah, it's going to be awesome once I finish it. It's going to be awesome, I promise. Okay, so this is all great. I just don't know what the password is. How can we... Where can I check that? So that is the only thing. Shit, man, what was it? That's so weird. Okay, let's ask the robot, right? I don't remember that. We need to also update the document. But what is the default password word for PG native cluster? Oh, I see. Yeah, exactly. Yeah, okay, so that's kind of what we made a mistake at, right? Okay, I see. So it's okay. That's great. My Postgres cluster. Okay, so you see, this is what I've been doing before. And this is what we're going to do. Now it's going to create a secret, right? Okay, that's actually interesting. I haven't gotten to config maps and stuff yet in Kubernetes, right? So I guess this YAML sets up a secret with password for the Postgres user. You would need to create a Kubernetes secret beforehand. Okay, let's not get there yet, because I'm a little bit worried. So this is fine, I believe. So let's stop the actual proxy, and let's apply this. Let's reapply this again, just so it creates this. I'm gonna do this, and then we're gonna do get. I don't know actually how long does it take for it to cluster in a healthy state. And then this, in theory, should be the password now, right? In theory, yeah. Oh, there we go. Okay. So now we're technically connected to our Postgres cluster inside of Kubernetes. Awesome. So now I'm connecting from this computer, from my computer where I'm streaming from, because we're port forwarding here. Okay, great. So we can see that indeed we need this. And this comment basically that I had here was something I wanted to do, because whenever the cluster is created, it's going to create this default app database, which I didn't like. But then there are some reasons for that, which I then agreed after I learned. Because CloudNativePG operator suggests that you create a not new database per app, but a different server or cluster per each app. And that's apparently because Postgres, a lot of Postgres features operate on the server level, not on a database level. So you basically keep your application, a single application per a single server. So if you do different versions of Postgres for different applications, so you can deploy, for example, 3 different clusters of Postgres, and they might be different versions, or they might have different permissions, blah, 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 blah. So their team, if I remember, I think I read it somewhere here under the frequently asked questions. Actually, if we go to documentation, yeah, this was. So there's some awesome questions answered here. Amazing. Yeah, exactly. So here it is, right? How many databases should be hosted in a single Postgres instance? Our recommendation is to dedicate a single Postgres cluster intended as primary and multiple standby servers to a single database entirely managed by a single microservice application. However, by leveraging the Postgres super user, it's possible to create as many users and databases as desired. The reason for this recommendation lies in the cloud native concept based on microservices. In a pure microservice architecture, the microservice itself should own the data it manages exclusively. Agreed. These could be flat files, queues, key value stores, or in our case, Postgres relational database containing both structured and unstructured data. The general idea is that only the microservice can access the database, including schema management and migrations, right? And I agree with that, right? It's just how efficient that's going to be in this K3S cluster, I don't know yet. We'll learn over time. Because fundamentally, with every cluster, we're hosting another container with the same fundamentally database, right? But they're saying, hey, they should ever only be, for sure, localhost, for sure, definitely. I mean, for us, certainly, right? But I agree with the sentiment. I think it makes total sense, right? It makes total sense in my opinion. Like, nothing they're saying here is wrong, but additionally, as you said, it would be an overkill for us. Okay, that's great, actually. So now we got that. Is there any changes that we have to? Just gonna push this to. All right, so that's awesome. Superb. That's great. And again, I'm not going to expose the Postgres cluster outside of the cluster itself. So that's awesome. So yeah, so whenever if I need to do something from this machine, I can always port forward like this, and that's awesome. The only actually thing that I need to update here is just add a bit of documentation. So And what was the namespace of it? Fuck. PostgreSDB. Okay, I'll just need to add a line of documentation. To access Postgres, you'll want to port forward from your local machine to one of the Postgres pods. Let's first list the services exposed by our PG operator. You'll get something like this. We can expose a, I guess, read-write service by running and I'll just give it to this read proof. I don't know, actually. I think no. What is a C? What was a CSI driver? I'm sorry, my brain is kind of dead a bit. What was it for? Container storage interface. Yeah, but what does the driver do exactly? What is it for? We're using Longhorn for storage, right? That's already done. We're using Longhorn, and we have already provisioned some volumes, as you can see, and we have a bunch of hard drives, SSDs that I bought. So if you're referring to the storage, that's already done, and it's all fully documented also as part of this repository. Longhorn is the CSI. Okay, got it. I'm sorry, I didn't know what the CSI, but when I read the acronym, it makes sense. It's Container Storage Interface, I think. Right? I think that's Container Storage Interface. Yeah. Yeah, Longhorn is now awesome. That works perfectly. As you can see, we have 6 SSDs. I dropped all the SD cards. And you have all of it under hardware, so everything is documented there. Okay, great. I just wanted to thank everybody for your follows. All right, so let me just read this, and then I'm pushing this. To access Postgres from your local machine, you'll need to port forward one of the Postgres services. But I don't want to like write more. I mean, it's. I think it's fine. It's sufficient for now. Okay, good. Just push this. Cool. Push it. Amazing, amazing. Okay, so that's great. The only thing we really don't have now is Metal Load Balancer. I made this graph. I drew this graph using a Mermaid for So basically the only thing, so we have Traefik ingress right now that's working well. We can see that my Longhorn is under the etc host here. We also have Traefik exposed locally. So we can see some things here in the Traefik. We can see that it's exposing metrics as well. So once we set Grafana and Prometheus eventually, I don't actually care about it now because I don't need it for anything. But so we can see that our ingress is working as well. But we need to put the load balancer in front of our ingress, right? So we'll need to set this up again. And I've already set up the IP pool on my MikroTik router, right? So if we go here to DHCP server and we go to, if we actually go to IP pool, we can see that we have basically the current DHCP here is issuing IPs from 100 to basically to 254. So everything less than 100 will go for our metal load balancer. One thing whatsoever that I disliked last time when I set up the load balancer is that I used their layer 2 algorithm, but they also support some networking protocol that I never worked with. I think it's BGP. So let me just read a little bit about it. Okay, let me actually ask give me a second. So I'm going to go to, it's actually quite ironic. I worked as a Cisco engineer at the start of my career, and I don't know what it is. It's a bit ego hit. So let's, I need to read a bit about that. So BGP, I want to set up MetalLB with my K3S cluster, and I would like to use their more advanced algorithm that uses, BGP. Since my MikroTik RB3011 supports BGP, it seems I can utilize it and get the best out of MetalLB. Whatsoever I'm unfamiliar with BGP, let's call it a protocol, I guess. So explain it to me first in simple terms, and then how can I set it up on my MikroTik? I see. Okay. Yeah, honestly, I mean, I worked with so much Cisco and MikroTik stuff back in 2007 and 8, but never. I set up designated networks. I worked with wireless OSPFs and stuff like that, but never this. Okay, let me just read. BGP Border Gateway Protocol is the protocol underlying the global routing system of the internet. It helps routers determine the best path to send data from one network to another. Imagine you're trying to send a letter to someone far away, let's say from your city to another city. There are many possible routes you can take, each passing through different cities, analogous to different routers. And BGP is like the post office system where the different ports offices communicate with each other to determine the best, most efficient route for getting the letter. Okay. If your local routings with your home network handle internet traffic, BGP is what allows those routers to talk. BGP routers learn multiple routes from peer routes in different networks. In your case, using BGP with MetalLB allows your cluster to directly advertise IPs to your MikroTik router when load. Okay, because just I see. Because as far as I understood here, let me show you. So the biggest problem. So just to show you what I think is the issue, right? So if we go to MetalLB, if we go to concepts, you can see that MetalLB runs in a layer 2 mode, and then it runs in MetalLB, basically BGP mode, right? The problem with the first one, which is very easy to set up, I see. Bear with me for a second. So you can see the problem with the layer 2 mode here is that if we use this load balancer there, then we are still creating a single point of failure, because apparently this fella is gonna, you can see limitation, layer 2 mode has two main limitations: single node bottlenecking and potentially slow failover. Because basically still, we're gonna always be load balancing through a single node. So that is, I don't see how that's useful, right? I don't actually even see how is that load balancing anything, because this is what their layer 2 is gonna do, right? So if this guy is throttled, then everything's messed up, right? Whereas we can get things like, this is our router, right? But you get the point, right? So that's why I, but let me read a little bit more. So yeah, this is the core, I guess. In your case, using BGP with MetalLB allows your cluster to directly advertise IPs to a MikroTik router when load balances are scheduled. This way, you'll be able to utilize BGP for the load balancer in an efficient manner without needing to manually carve out IPs from your router config. Equal cause multi-padding, which you can't get. I see. Your RB. Keep in mind, Sparta. I've been working with networking on that level many years ago, so it might. My brain might be very slow relative to yours now. It's been many years. Give me 1 second. But hearing you talk, I'm so proud, man. I remember these days. Sometimes I regret that I kind of left that career, but I'm actually happy financially. I worked as a Cisco engineer from 2007 until 2010. And I saw back then that the unfortunate part of that work, of that job, was very slow progression, if any. Yeah, good. Well, you did the same as I did. You did the same as I did. Okay, so to be very frank with you, I will configure this, but not on the stream, because since I have to mess up with my Winbox over here and stuff, I don't feel doing this on the stream. I need to be very careful, and I need to do a backup of my MikroTik OS, because yeah, I mean doing these YAML files and creating services and whatever. But I can see BGP peer here, this guy, and I'm unfamiliar with this, so. But I can see a routing BGP instance, right? And then we would create an instance here. I'm just planting the idea in my head here. I see how this is going to work. It's actually going to be pretty awesome, to be honest. This is going to be pretty awesome. Nice. Yeah, I'm actually excited about this one, especially learning a little bit more. I need to read about the protocol. I need to understand. Dude, remember this Sparta? I remember when I was at Cisco Academy, just looking at oh man, do they still have Cisco Academy website? I used to spend a lot of time here. Netcad, yeah. Is there still packet tracer? There's still packet tracer, right? Yes. You have to. Wow. Wait, you can't. Give me a second. I don't remember most of these things. Nah, I don't want to sign up. I must have an account here, man. What the hell? Page has expired. What? Go back. All right. Try again. Come on, SSO. Come on. Update account information. Yeah, exactly, man. You're pretty much describing what I saw many years ago, and I'm happy that I was right. I'm sorry. I just must do this. You just triggered me, yeah. Just want to see what they did with this website. My learning profile. Country or region Romania. What the fuck? All right, never mind. They did something new here. Okay, screw it. All right, so before I'm not gonna do MetalLB today. So wait, so I did set up two SSDs, set up native PG operator today. So we're not gonna do the metal load balancer today, but we're gonna take a look at the backups, right? That's something that I really want to do now, very badly. I kind of generated, or to say, semi-wrote. This is part of the guide over here. Backing up K3S cluster. Let's research a bit. Let's not reinvent the wheel, right? K3S etcd backup and snapshot explained. Super. So we create some cron job here. That's so nice, man. Wow, really? That's awesome. Okay, let's read this. Bullshit preparing class. Before installing K3S in our server, we're going to create two directories, one for the backups and another for the snapshots, okay? As you'll see, the snapshot directory is going to grow in size due to multiple snapshots, depending the frequency of them, and also depending on how many resources the cluster has. So plan ahead if the cluster is going to allocate many pods with big images. If the requirements start to be heavy, it might be necessary to pass the folder to an external disk, or even to store a cloud provider with S3, for example, for which K3 has support. To install K3S in our Linux server and configure the snapshots and backups, we're going to, in a single command. So he's disabling the ingress controller, setting up some permissions, setting some data directories and stuff. And this is interesting, right? I haven't done this. So now it seems to me we need to figure out if we can, in fact, configure these directories manually again. And then what I really like here is the cron job. I didn't know that you can do this. This is pretty awesome. etc snapshot schedule cron. It's easy to see how the cron command is programmed to be executed each 3 hours. Then the retention period of the snapshot is 72 snapshots. If we multiply the 72 snapshots by 3 hours, we get 216 hours. It gives 9 days of snapshots. Doing the same command, but for testing purposes, we can tell, yeah, so that's way too much. I don't think we're going to do that. Doing the same command, but for testing purposes, we can tell to execute a snapshot each 1 minute and keep 3,600 snapshots. Yeah, I don't get it fully, honestly. Let me read this. It's too much. The way K3S is backed up and restored depends on which type of data store is used. In addition to backing the data store itself, you must also back up the server token. Yeah, actually, I'm aware of this. You must restore this file, blah, blah, blah. Yeah. Okay. No special commands are required to back up or restore the SQL database store, SQLite store. To back up the SQLite, take a copy of this. To restore SQLite, restore the copy and token as discussed above. When an external data store is used, backup and restore operations are handled outside of K3S. The database administrator will need to back up the external databases or restore it from a snapshot or a dump. We recommend configuring the database to take recurring snapshots. So I suppose there, in our context here, we could say we are referring to the PG native operator. That is really our own database. So they're saying, hey, Alex, if you're using external database, and if we're not talking about Etsy or anything local to this K3S thing, well, it's your responsibility to back it up, right? Which makes sense, I suppose. And now this is what I'm interested in. This page documents the management of the etcd snapshots using K3S etcd snapshot CLI, as well as configuration of etcd scheduled snapshots for K3S server process and use of K3S server cluster reset command to reset etcd cluster membership and optionally restore etcd snapshots. Snapshots are saved to the path set by the server's etcd snapshot dir value, which defaults to data dir server. I see. So if we do this, so if we, let's say, SSH into one of the, let's actually, yeah. So and then snapshots, right? Right now, it doesn't seem that we have the snapshots because there's none, right? Yeah. So I suppose the directory is going to be created when there's at least a single snapshot. Okay. Scheduled snapshots are enabled by default with 5 snapshots retained. To configure the snapshot interval, scheduled snapshots are enabled by default. To be very frank with you, I just want to learn the way that these guys suggest, right? I mean, I'll do some sort of manual backup anyway, just back stuff up here to some external drive that's outside of the cluster. And I do that with programmer network platform that we built and that we're going to be building. So I'm old-fashioned in that sense. When I do backups for programmer network, I have a cron job that uses rclone and it backs the database 4 times a day. So I just use the rclone to Google Drive, right? But here I want to learn what these guys suggest and then respect that. Good evening, VPNville. Yes, man, of course. And this is what I care about, right? Snapshots can be saved manually by running the K3S etcd snapshot save. On-demand snapshots have a name that starts with on-demand, followed by the node name and timestamp. The base name can be, okay. Why do you need a desktop PC? Let's just make a step back. So why do you need a desktop PC for programming? Well, you don't need a desktop for coding. That's the whole point. So I just want to make sure that you're honest with yourself. You don't need a desktop for coding. You do need desktop for gaming. So let's not pretend that you're buying the desktop for coding, right? You're not, because that makes no sense. You don't want to lock yourself to a physical place for coding, right? You want to, well, so you need it not for coding, you need it for gaming. And that if you get a gaming computer, then it's naturally good for coding as well. So if you buy any gaming, you don't need a desktop computer to build web pages. You can do that on a 10-year-old laptop, right? So that's why I'm exactly asking, right? Are you being honest with yourself? You can do coding literally on Raspberry Pi, especially Raspberry Pi 5. You can spend 100 euros or a bit more and you have a coding PC, right? So yeah, but it seems that you need a computer for gaming and some coding, not vice versa, right? Because if it's the other way around, then you don't need a desktop computer at the first place. Yeah, I don't know. None of this really aligns with what these guys are saying. So what happens if I do this, right? Command K3S. So if I go into my main node, what? I think it's a permission issue, right? Yeah. What? No. Yeah, but I don't think it's not a permission. There's genuinely no. Yeah, for sure. There's various solutions. I agree. There's various solutions out there. It's just I think that the person who asked the question doesn't really need a computer for programming. They need a computer for gaming, and that is simply the truth, right? I'm not saying that that's good or bad. It's just it's good to know the context, right? Because you don't need a desktop for programming, right? Yes, so the path is wrong. Where is this path set? No. The thing is, look, I'm just trying to give the accurate answer. We shouldn't get into budget or whatever. The point is, if you need a computer to genuinely write code, laptop is your best bet, right? That's the whole point. That's if you need a computer for gaming, that's no brainer. Like depending also what games you want to play, right? Do you want to play a World of Warcraft that's 20 years old, or do you want to play some latest cyberpunk shit, right? That depends. This computer I'm streaming from is a very insane computer. It's a 16-core CPU, RTX 4070 Ti, right? And I built this computer for streaming. So if you see 4070 Ti, 16-core CPU, 12 generation i9, 2900K, DDR5. I mean, I could run it in 6000, but I would this live. I say, oh, I need this for programming. I need it to run all of this shit, right? And also to game. I don't have the time, unfortunately, but I think I remember that I have some Ansible thing. I don't think that that's the case anymore. RLI, that has been the case many, many years ago. I remember 25 years ago, that was the case almost always. Today, is there some laptop maybe where that's the case? Sure. But I would say that's incredibly rare. Incredibly rare. Storage, wait, what did I want to do? Yeah, so Ansible, let me actually take a look at that. So where did I put these files? Static, Ansible, yeah, playbooks. Yeah, kubeconfig. So there's this kubeconfig thing that I did that could have messed this thing up. So this is correct. That is temporarily setting that, installing this with the token, fetch the. I see. Okay, fair enough. Fetch kubeconfig from master. Yeah, I don't know. I just suspect that this potentially could be a problem. All right, it doesn't really matter. We don't have to do it now. But this is definitely the next thing we want to do. Oops, sorry. So everything's now running. We have 6 SSDs plugged in there. So that is awesome. That is actually pretty cool. Which operating system you're using, it doesn't really matter at all. You can use whatever you want. I use Mac for work. I stream from Windows computer that runs Windows Linux subsystem. My laptop is running Ubuntu, so, and that has been the case my whole life. So it doesn't, pick whatever you, who cares? Nobody cares, man. Nobody. The core question is, are you productive or not? Which operating system you use, nobody gives a crap. Okay, let me just write some notes. So what did we say? So we want to set up BGP. Set up BGP with RB 3011 and MetalLB. Yeah. figure out the backup, figure out why, what was it? Why K3S etcd snapshot etcd snapshot save doesn't work. What else do we have to do? So we have the Postgres. It is Joe Satriani. Yeah, I actually met him. I met Joe Satriani. I'm a guitarist, as you might, and I'm a musician as well. I met him several years ago in Budapest with my wife. I paid us a VIP ticket. Nice, man. Nice. Jazz master is. I have a friend, Sinisha, who has a jazz master as well. I'm a more of a. I play music. I have Joe Satriani's guitar as well, the white one, actually. Give me 1 second. So, so this is the Ibanez.js actually. So you can see here, maybe I have a blur enabled now, but this is his. This is his model. This is one of the. Yeah, but I can show you. I see. Let me show you. So this is Joe, myself, and my wife. This was, when was this? This was like in 2018. So this was like almost, what, 6-7 years ago. So this is in the backstage. It was super awesome. This is Mike Joe's. This is Mike Joe's sound guy. This is in the backstage. And then, yeah, here's the white guitar. This one that I'm. Hear me sweating, trying to ask a question. This was so awesome, man. This was amazing. Give me a second. Let me just. But yeah, I'm playing saxophone as well. I have a beautiful sax here, right behind it. This is the saxophones. It's called Saxo Mute, so I can practice at home. But yeah, it's pretty awesome. Pretty awesome stuff. Give me 2 seconds. Yeah, I think I'll need to round up. I need to go to work tomorrow, and I had a long day, so let's just round it up. Yeah, what can I say? Thank you, guys. Every day, whenever I have the time, I'll stream. Maybe I'll stream tomorrow, maybe not. I don't know. I'm not a typical streamer. I do this when I want, when I find it fun, when I have something to learn or whatever. So, but either way, yeah, thank you everybody, especially the new people. Sparta, thank you for joining the stream. Fuji, thank you for the follow, and everybody, the rest of you guys, thank you very much for being here. I need to go now and get ready for bed. So goodbye, and I'll catch you guys up another time, okay? Goodbye to you as well, Rafi, as well. Sleep well. Fuji, you too. Have a good night, everybody, and I'll talk to you some other time.